Hello everyone, my name is Kim Kwang-min. I belong to Nanobiomaterials Lab from SKQ Chemical Engineering Department. Today I'm gonna introduce my research. The title is Fabrication of Orally Administered Biomaterials for Effective Inflammatory Bowel Disease Treatment. Firstly, I briefly explain what inflammatory bowel disease is. IBD is one of the autoimmune diseases occurred in gastrointestinal tract by excessive immune response. Although the mortality rate of IBD is much lower than other autoimmune diseases, these symptoms lessly affect their daily life. As you can see left image, numerous factors affect IBD, even the environmental or genetic factors. From the advent of Industrial Revolution, IBD has been increasing, and from the statistical data in Korea, $170 million have been paid for patients every year. Moreover, according to the data, most of IBD patients have other complications like skin, ocular, and so on. To deal with that, some of drugs have been applied to IBD treatment with downregulation of immune response, such as biosimilar drugs and cytokine inhibitor, immune suppressive drug, and integrin inhibitor. However, these kinds of drugs not cure the disease, but just decrease symptoms. So, to overcome these limitations, we need to develop new strategies for effective IBD treatment. In the meanwhile, inflammation have been reported to highly correlated with production of reactive oxygen species ROS, such as superoxide anion, hydrogen peroxide, and so on. Once ROS is overproduced by inflammatory stimuli, it activates NF-kappa B transcripts, and it further expresses pro-inflammatory cytokine, resulting to inflammation. Taken together, ROS production is highly related to inflammation. So, in my first research, to reduce ROS level in inflamed tissues, I use serial nanoparticles as natural antioxidant enzyme like SOD and catalase activity. Contrary to natural enzyme, serial nanoparticles have resistance to pH and temperature and easily made and synthesized. Furthermore, from the oxidation state, they scavenge ROS catalytically. And then we have to consider how to deliver therapeutic material to inflamed tissues. Among the administration routes, oral delivery has convenience route, patient preference, cost effectiveness, and ease of large-scale manufacturing. So, for delivery of serial particles to colitis, I introduce mesoporous silicon nanoparticles to load serial nanoparticles on their surface as much as we can, and then coated PAA polymer, which can be much adherence to inflamed epithelium. So, firstly, we characterize the material in physiological condition, PBS, pH 7.4. Left data shows colloidal stability with or without PAA coating process. As you can see left image, with PAA coated, I can show excellent stability, but with non-PAA coating process, AN is much unstable in PBS. Furthermore, in ROS scavenging activity data, I can exhibit comparable natural antioxidant enzyme-like activity such as SOD and catalase activity. Next, for effective oral remedy for treatment of IBD, we evaluated its durability. To do that, we incubated icons in artificial gastric fluid, page 1.2, for 2 hours. From the elementary analysis data, serum ions still exist in material and had negative surface charge and exhibit over 19% SOD and catalase activity, even they incubated in acidic environment for 2 hours. Next, we evaluated in situ antioxidants effect of icons in inflamed colon mimic system. So firstly, we used co-culture environments with epithelial cells and macrophages. And then to induce inflammation, we treated LPS, resulting to overproduction of RS and pro-inflammatory cytokines. Therefore, by phantom action in epithelial cells, ferrous ion convert to ferric ion more and more, and it affects the expression of positive charge protein on epithelial cells. So we treated dye-conjugated AN and ICAN on inflamed colon mimic system, and then checked fluorescence images of epithelial cells. From the below left fluorescence image data, negative surface charged icons exhibit much strong signal compared with AN-treated groups. Moreover, from the inflammatory cytokine level in media, I can significantly decrease their levels compared with untreated groups. It indicated that icons can be in situ antioxidant effect on inflamed colon mimic system. Next, we checked whether icons exhibit preferential adherence to IBD during colitis. So, firstly, we induced IBD for 7 days and orally administered dye-conjugated AN and ICAN to mice. After 24 hours, we collect colon and check fluorescence intensity by ex vivo imaging. As you can see right image, even after 24 hours, ICANS is much adherence to colitis compared with AN-treated groups. So, we anticipated our inflamed colon targeted non-therapeutics can be applicable to IBD treatment. This slide shows representative in vivo data on collect tissues regarding to oxidative stress, immune response, and infiltration of inflammatory cells. In above data, I quantified peroxidase enzymes and their activity as oxidative stress factors and pro-inflammatory cytokines such as TNF-alpha and interleukin-6 as immune response markers, respectively. As you can see above, ICAN-treated groups much decrease oral levels compared to DSS water and AN-treated groups. In the meanwhile, severe inflammation caused progressive inflammatory cells infiltration into the inflamed tissues. Below data are blue and green composite IHC images indicating to infiltration levels of inflammatory cells into the tissues. As you can see white data, in ICAN-treated groups, green signals, which means for CD11b positive inflammatory cells, highly decreased compared with untreated groups and AN-treated groups. Taken together, I successfully fabricated inflamed colon targeted nanotherapeutics for IBD treatment. In my future plan, I am also trying to make several orally administered nanocomposite biomaterials for IBD treatments and their complications. This is my end of presentation. Thank you for listening.